Hey all, hopefully this will just be a quick video about 1.6 properties of numbers. In the last lesson, or section 1.5, we talked about I showed you some properties of square roots. These are just properties of numbers in general, and if I'm still doing things the same way I am now, then this should be the last section of this chapter. But let's, again, hopefully trying to make this a relatively quick video, just kind of going through these properties. So let's dive right in. So this might seem familiar to you from middle school or wherever, but there is a commutative property of addition that basically says that when adding two numbers, it doesn't matter what order they are written in, okay? So if you're doing 3 plus 8, you could rewrite that as 8 plus 3. So that's the commutative property, and a lot of these are going to be like, well, yeah, no duh, because the concept of adding or multiplying or whatever, it's not that deep of a concept, and your brain can wrap itself around those concepts to where that when you do 3 plus 8, that's literally the same as 8 plus 3. It doesn't matter how you write it, you're still adding 8 and 3 together. So but the commutative again, some of these are like no duh properties, but we just want to give them names. Now there's also a commutative property of multiplication, same sort of thing, but instead of for addition, it's multiplication, because again, you know that 3 times 8 is literally the same as 8 times 3. It doesn't matter what order you write them in, okay? That's the commutative property of multiplication. Not going to move on right away, but I am going to be, if I move on again, as always, feel free to pause the video so you have a chance to write anything down that you need to. But before I move on, what do you think? Do you think there would also be a commutative property of subtraction? Would there also be a commutative property of division that we could write? In other words, is 3 minus 8 literally the same as 8 minus 3? So could we also say there's a commutative property of subtraction? And of course the answer is no. 3 minus 8 and 8 minus 3, they're not the same. And the same goes for division, right? 3 divided by 8 is not the same as 8 divided by 3. So with subtraction and division, it matters which number you are writing first. But with addition and multiplication, it really doesn't. So moving on. There's also something we call the associative property of addition, as well as for multiplication. So this is essentially a property that says, and again, some of this is like, no duh. If you have 3 numbers to add together, it doesn't matter which 2 you add first. So in other words, if we had 3 and 5 and 4, we're just looking to add them all together, 3 and 5 and 4. Doesn't matter if you add the 3 and the 5 first, or the 5 and the 4 first, or I guess I'll just leave it at that. So this is the associative property. It doesn't matter which 2 you add first. Similarly, if you have 3 numbers that you're multiplying together, you just want to do 3 times 5 times 4. If you want to do 3 times 5 first, it's all good. You'd get the same answer as if you multiplied 5 times 4 first. So it doesn't matter which way you do it. It doesn't matter which 2 numbers you multiply first. And again, subtraction or division, no, because it would matter. Okay, if you do 3, we'll just kind of leave it at that. I don't want to go too deep down that rabbit hole. But if you want me to do that in person or in the next class, just let me know and I can go into detail about, but you can, I don't know, you may not need me to. Like, you could probably figure out for yourself why this property wouldn't work with subtraction or the operation of division. Next, we would have what's called the identity property of addition as well as multiplication. So identity, like think of identity theft, or think of your identity. You know, losing your identity, or someone stealing, you know, your identity. So that it's a good name for this property, because here's what this property says. So for addition, the identity property says essentially, when you add 0 to any number, it doesn't change it. You know, it's not going to lose its identity, or in other words, it's going to keep its identity. So if you do any number plus 0, it stays the same. It doesn't lose its identity. So there's a similar property. There's a similar property for multiplication with, you know, the identity, okay? So when you multiply a number by what? It doesn't change its identity at all. What number would go here? 1. So for example, if you do negative 19 times 1, it stays the same. It doesn't lose its identity. No identity theft. If you've ever watched The Office, identity theft is not a joke, Jim. Millions of families suffer every year. Next property, we have the inverse properties. Okay, here we go. Again with inverse. This actually ties into, or kind of refers back to, some other notes we took earlier in this very chapter. So inverse. So like, remember how we talked about like an additive inverse? So we've actually, you know what? We might have already written down this very property, just never with this official title, okay? Because remember when we were talking about additive inverses, okay? So when you add because remember, the more common, easier way to say additive inverse is just opposite, okay? So it's a property, we call it a property. When you add opposites together, you always get 0. We literally wrote that down already. So what's the additive inverse or opposite of 5? So 5 plus, because when you add 5 with it, negative 5. Yeah, we know that. It's not that tough of a question as long as you understand what I'm asking. You know, like what's the opposite of 5? Negative 5. So remember, there was also something with multiplicative inverses. When you multiply, and I think I may have mentioned this in class, but you know how opposite is probably the more common way to say additive inverse? What's the other way to say multiplicative inverse? Because something you might learn about me, or from me, I guess, I don't know. I don't like how often the word inverse gets tossed around. Or maybe I should say it this way. The word inverse in mathematics has way too many like subtly different definitions. You know, there's all these different slight variations on like definitions and ways you can use the word inverse. It's almost like an overused word, maybe. So instead of saying additive inverse of a number, we just probably best just say opposite. And instead of multiplicative inverse, we say reciprocals, or what I sometimes say, reflipricals. Get it? You know, and again, we already wrote this down earlier in an earlier lesson, this chapter. Whenever you multiply two reciprocals together, you always get 1. Ooh, I'm glad I have 2 examples here. So 3 times what is 1? What's the reciprocal of 3? Just like 2/7 times what equals 1. What's the reciprocal or the multiplicative inverse of 2/7? Why do I sometimes refer to reciprocals as reflipricals? Because you flip it to get the reciprocal. So 2/7 times 7/2, that's going to be equal to 1 because they are reciprocals of each other. And what's the reciprocal of 3? If you flip 3, what do you get? You probably should already know that it's, oops, sorry, so some current events here. Oh man, it changes. Whoa, it keeps changing. Yeah, today is January 29th, 2024. In case you want to, I don't know, look up some of those events from the, I don't know, taskbar, feed, whatever, weather, news. Sorry, I hate when that happens. Almost done, I think. Almost done, right? Couple, yeah. Nearing the end. The symmetric property. So things that are symmetric, you know, you could like draw a line down the middle and it's almost like mirror images on either side kind of thing. So it's probably a pretty good name for this property. That property, again, this is like such a no-duh property. Like, there's a property that says that, yeah. Isn't it just common sense? The left and right sides of an equation can be switched. So as an example, if you can say 4 plus 2 equals 6, you can also say, remember, the left and right sides can be switched, no problem. Then you could say 6 equals 4 plus 2. I'm thinking, let me get out of my seat here. So I don't want to write with my mouse. So hopefully you can still hear me. But maybe a better example of this symmetric property is, you know when you're solving an equation, what color am I using here? Purple. So here's maybe a better example. You know when you're solving for x and you just end up with your variable on the right, so you end up with like 6 equals x. Well, like, you know, if you're like me, I'd much rather write my final answer as x equals 6, you know, because there's nothing wrong with that. Instead of writing 6 equals x, you just write x equals 6. And that's, again, it's common sense. I don't think anyone, I mean, again, no duh. But we call that the symmetric property. Okay? Yeah. So, hey, good news here maybe. Less to worry about for right now. But we're going to talk about the distributive property in a later chapter. Couple more properties. Multiplicative property of 0. Pretty good name, because all this property says is whenever you multiply anything by 0, what do you always get? We might have already written this down too in an earlier lesson, this chapter. So 8, or any number, whether it's, hey, whether it's real, or not, geez, what am I saying? Whether it's rational or irrational or a nice whole number, I mean, whatever, you know, whenever you multiply by 0, you always get 0. And I might as well throw this in, right? Back to the board I go. If you were looking for, I mean, this is a very specific example, but if you, like, I think we wrote this down earlier in the chapter, something like a, you know, a times 0, just keeping it like very open-ended. So you would see something like this in a textbook, you know, a times 0 equals 0. So likewise, I think we already wrote this down too earlier. The multiplicative, well, maybe not. Because there's a multiplicative property of -1. And what that says is, whenever you multiply by -1, so whatever times -1, if you were, you know, writing it all generalized, I mean, I suppose over here we have a very specific answer, examples. You know, what happens when you multiply by -1? Well, in general, like over here, okay, a, which could be whatever, right? Whether rational or irrational, it's all good. But if you do a times -1, you're just going to get negative a. Like whatever a was, you end up getting negative that, negative whatever, negative a. So 3 times -1, negative that, you know? And then -7 times -1, you get like the opposite or the negative of negative 7, which is positive 7. So I think that was it, right? I know on this last slide it's like, could we talk about the reflexive property? Probably not, at least not in this video. There's also something called a transitive property that we're probably not going to get into, so let's just stop it right there. Thanks for following along with section 1.6.